Hi, me again, QE-4, quadratic formula. Oh my goodness, what a fun thing. It's like that Starburst commercial where they say the quadratic equation. This is the quadratic equation. Okay, so solve the equation x squared plus 8x plus 3 equals 0 by completing the square. So it actually told us to complete the square. Alrighty, so that's the first thing we're going to do here. Here, let me make this bigger. Completing the square. So if you remember, completing the square is when we have to fill that double bubble where we have x squared plus 8x. We leave a place plus 3, and we leave a place, and we're going to set that equal to 0 because that's what it has here, okay? And then what we're trying to do here is find what number we both add and subtract so we can factor this portion and then just simplify this one, okay? So how do we get that number again? We're going to take this b term and we're going to divide it by 2. So I get 8 over 2, which is 4. And then I square it, which is 16. So that's the number I'm going to add and subtract. Okay, and then this portion right here is perfectly factorable because we turned it into a perfect square. 16 is a perfect square, remember? So I need the same number that multiplies by itself to get 16 and adds to give me 8. Well, we already found it. It's always that b over 2 number. Okay, so it is 4. So when I write this, I'm going to get x plus 4 squared. And then I'm just going to simplify this thing down where I get 3 minus 16, which is a minus 13, equals 0. Okay, so now we're at the stage in the game where we were yesterday where I'm solving something that's in vertex form. So I'm going to actually rewrite this up here. And we're going to go ahead and solve it. So if I want to solve it, I'm going to cover the x because that's the last thing I want to touch. And I'm going to move my constant by doing inverse operations. Okay, so the inverse of minus is add. So I'm going to add 13 to both sides. Go back to the beginning and bring down what I didn't use yet. So x plus 4 squared equals 13. Okay, I'm going to cover x. And what I see here is the squaring of something. So the inverse of squaring is the square root. Okay, that cancels this. And I do it on that side too. So out jumps x plus 4. And remember, I have the plus or minus 13, radical 13. Because when I take a square root, I have a positive root, the principal root, and a negative root. Okay, I'm going to cover this, and I say subtract 4 from both sides. And what am I left with? I'm left with x equals, I'm going to write the minus 4 first, plus or minus radical 13. Okay, so it says what type of numbers does your answer represent? So if I have negative 4 plus radical 13, okay, well, what type of number is this? Rational or irrational? Rational or irrational? Well, math, fraction, well, they look irrational, okay? Both solutions are irrational because I cannot turn them into a fraction. Okay, they're irrational because you cannot turn them into a fraction. So what we're going to actually talk about today is another way that you can find the zeros, okay? It's called the quadratic formula or the quadratic equation, and it's for quadratics that are in standard form. So you must be in standard form first. So if you are not in standard form, aka everything is all combined and set equal to 0, you cannot actually use the quadratic formula. But the quadratic formula looks like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what we're going to do here is we're going to use the same quadratic equation as the first example, and we're going to solve it by actually doing the quadratic formula, okay? So what we're looking for is I want to identify the values of A, B, and C in the quadratic formula. All right, so let's look at this again. A squared plus 8x plus 3 equals 0. What do I have here? I have, if I put it in standard form, it should match these, right? Where this is the A value, the number in front of the X, this is the B value, the number in front of the B, and this is the C value, okay? So just remember to always include your signs too. So A, well, what's actually here if there's nothing written? Well, it's a 1. B, okay, well, it's the number that's in front of the X all by itself, which is a positive 8. And C, well, this is the 3. Okay. Now what I'm going to do is I'm going to carefully substitute these values in the quadratic formula and simplify my expression. Okay, so I'm going to use this formula, and I'm going to use A, B, and C. So wherever I see a B, I'm going to write 8. Wherever I see an A, I'm going to write 1. Wherever I see a C, I'm going to write 3. So I'm going to get X equals, negative is part of the equation. B, well, B is 8. The equation says plus or minus the square root B squared. B is 8. Minus is part of the equation. 4 is part of the equation. A is 1. And C is 3. And all of this is over 2, part of the equation, times A, which is just 1. Okay, so now what we're going to do is just simplify. Can simplify negative 8. Okay, plus or minus. I'm going to leave the radical, but I'm just going to simplify the numbers underneath it here. Okay, so I'm going to do 8 squared minus 4 times 1 times 3. So this is radical 52 all over 2 times 1 is 2. I guess I didn't have to make this radical so large. Okay. So radical 52, simplest radical form. I think that we can simplify this a little bit. So let's do some birthday cake work. Okay. 52 is even, so I'm going to start with 2. So 52 divided by 2 is 26. 26 is still even, so I'm going to stick with 2. 26 divided by 2 is 13. 13 divided by 2 is not going to work. What about 3? No. 4? No. 5? No. Okay, so we're running down that list. It's going to be 13. And there's your birthday cake. Okay, so you're going to circle your pair. The pair comes out as 1. And this one doesn't have a pair, so it stays underneath that radical. So you're left with 2 radical 13 as your simplified version of radical 52. So I'm going to come over here, and I'm going to write that down. So x equals negative 8 plus or minus 2 radical 13 over 2. Okay. Now, do you remember when you were adding and subtracting things as fractions and what a common denominator is? A common denominator means that this 2 is shared underneath everything that's being added and subtracted up here. So it was actually saying negative 8 divided by 2 plus or minus 2 radical 13 divided by 2. And then I can simplify this out a little bit. So negative 8 divided by 2 is negative 4. And then plus or minus, the 2's get to cancel, so I get radical 13. Okay, well, what does this look like? Looks like this. Okay, so these two things are perfectly equivalent. You may not have to take this extra step too often, but for this example, we just wanted to refresh that little fact. Okay, so we're going to do a couple more. And what we're going to do here is just use the quadratic equation. So I'm going to use the quadratic formula on this. And when I do that, the first thing I have to identify is what is A, B, and C. So A is the number in front of the x squared, which is 1. B is the number in front of the x, which is a positive 6. And C is just that constant, which here, be careful, is a negative 9. Okay, so now I'm going to plug it right into here. So I get x equals negative b. B was 6 plus or minus the square root b squared, so 6 squared minus 4ac. So 4a is 1 and c is negative 9. Okay, all of this is going to be divided by 2 times a. A is 1. Okay, so let's simplify out here. So nothing to simplify here. Negative 6 just turns into negative 6. Plus or minus, I'm going to simplify just underneath the radical. And the reason I simplify just underneath the radical is because if I just plug this whole thing in here like this, 6 squared minus 4 times negative 9, I get an irrational number, and the quadratic formula says simplest radical form, so I need to leave everything in radicals anyway. So I'm just going to use what's underneath the radical and get that number output. Okay, so this is radical 72 all over 2. Okay, well, radical 72. Radical 72 is irrational, non-repeating, non-terminating. So that means I'm going to do some bubble work here, and I'm going to try and simplify radical 72 using birthday cake method. So 72 is even, so I'm going to start with 2. So 72 divided by 2 is 36. 36 is even, so I'm going to stick with 2. So 36 divided by 2, 18, also even. So I'm going to stick with 2. Not even, so I'm going to change it up. I'm going to go to 3, and 9 divided by 3 is 3. And then I get to stick with my 3, and then I get a birthday cake. Okay, I'm going to circle my pairs. Remember, this comes out as a 3, 1, 3. This comes out as 1, 2. And this one just stays in the radical. Okay, and then we have 3 times 2 radical 2, aka 6 radical 2. So that's what I'm going to do here. Negative 6 plus or minus 6 radical 2 over 2. Okay. Common denominator, so negative 6 over 2 plus or minus 6 radical 2 over 2. And then I'm just going to simplify here. So x equals negative 6 over 2 is negative 3. 2 goes into 6 3 times, so I get negative 3 plus or minus 3 radical 2. Okay, so that means this bad boy crosses the x-axis at negative 3 plus 3 radical 2 and negative 3 minus 3 radical 2, those two places. Alrighty, this second to last one, I get A is the number in front of the x squared, B is the number in front of the x, and C is that number all by itself, which is just a negative 1 here. Okay, let's plug it in. X equals negative B, okay, the B was 4, plus or minus the square root of B squared minus 4AC. A was 3, C was negative 1. All over 2 times A, which is 3. Okay, I'm going to simplify out. So -4, so -1 times -4 is -4, plus or minus. I'm going to simplify right underneath this radical first. So I'm going to have 4 squared minus 4ac, which is radical 28, all over 2a, so 2 times 3 is 6. Okay, radical 28, is that a perfect square? No, it is not. So I'm going to have to do some birthday cake work. Okay, well, 28 is even, so I'm going to divide it by 2 first. 14. 14 is even, so I'm going to divide it by 2, which is 7. 7 is not even, so I have to think about a new number. Remember my prime list. 2, 3, 5, 7, 11, 13. I said 7, right? Birthday cake. Circle your pair. Comes out as 1, 2. This is left alone, so it's a radical. Okay, so I'm left with 2 radical 7, and that's what's going to go in for this radical 28. So x equals -4 plus or minus 2 radical 7. Okay, common denominator, oopsies, all over 6. Common denominator says it can go under both numbers. Okay, and then I simplify. So how do I simplify 4, 6? Well, it's a negative. 2 goes into 4 2 times. 2 goes into 6 3 times. Plus or minus. 2 goes into 2 once, and 2 goes into 6 3 times. So this is just radical 7 over 3. And there's your answer. Okay, last question is more of an application. And I just want to say something really quickly. If you're getting a negative number underneath here, that is no bueno, my friends. That is no good. So that cannot happen. So if this number right here gives you something negative, you can't actually have a negative underneath there. Not until algebra 2 at least. Okay, so a projectile is fired vertically from the top of a 60-foot tall building. Its height in feet above the ground is this. Okay, so this is the height. And t is time. Okay, so this is the height output at any given time t. Using your calculator, sketch the graph of the projectile's height. And we're not going to solve using the quadratic formula, but so y equals, okay, so it says -16. It's a t, but I'm just going to use x squared because the t is just a variable. So the variable I'm using is x, plus 20x plus 60. I'm going to graph this, but my window is a little off because notice this window is going from 0 to 3 on the x-axis and 0 to 70 on the y. So I'm going to go to window, and the x goes from 0 to 3. The y is going from 0 to 70, and now let's look at that graph. Okay, so it looks, I'm just going to do a quick sketch. It looks something like 1, 2, 3. So looks something like this. Okay, so this is the ball. Here is the building. There are you. You throw the ball, and the ball goes, and we want to know when it actually hits the ground. So when it hits the ground is when the time is 0 because the ball stops. Okay. So I guess we could get some quadratic equation practice. So A is going to be -16, B is going to be 20, and C is going to be 60. Let's plug it in. So I get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, notice what this says. This says to the nearest 10th of a second. So this is asking you for a decimal. So what we're going to do here is plug 2 things into our calculator. Okay, we're going to plug the positive side of this. So we're going to get x equals negative 20 plus radical 20 squared minus 4, negative 16 times 60, AC, all over 2a. And then we're also going to plug in the minus portion. So, because I have two roots, right? Oopsies. So minus radical. Oh no, I'm going to run out of space here. 20 squared minus 4. Oh no, I'm going to go up this way. Negative 16 times 60. All over 2 times negative 16. Okay, and I'm going to show you how to do this in your calculator. So I want to first make a fraction. Okay, negative 20. I'm going to do the plus 1 first. Radical 20 squared minus 4. Oopsies. 4 parenthesis a, which is negative 16. C, which is 60. All over 2 times negative 16, which is a. So I get x equals negative 1 point to the nearest tenth is 1 decimal place. So the tenth, this is tenth, second is hundredth, okay? Tenth, hundredth, thousandths, 10,000ths, and so on. So if I'm looking at the nearest tenth, I'm looking at the 4, and the 0 tells me to go up or down. And since it's below 5, I stay down, okay? Alrighty, so now what I want to do is I actually want to go and highlight this whole thing. So notice what I did is I arrowed up, and you can't really see it, but it highlights it, and I'm going to hit enter. Okay, and when I do that, the only thing I'm going to change here, I'm going to arrow back to where I have this plus, and I'm going to change it to a minus. Okay, and then I'm going to hit enter, and this one is 2.10th is a 6. The 5 tells me to go up or down. So the 5 pushes the 6 up to a 7. And notice what I'm circling. I did not circle this one, and why not? Well, does it make sense that the ball is going to hit over here if our graph tells us it's going this way? Absolutely not. So right here, our solution is x equals 2.7. Oopsies. Oh my goodness. I guess we should say seconds to be technical. Okie dokie, have the most perfect day that you've ever had ever.